Hello guys, let's talk more about Lewis structures and formal charges, which will help us figure out which Lewis structure is the best. So the formal charge is actually the charge an atom would have if all the electrons in a covalent bond were shared equally. In order to calculate the formal charge, we have to know the number of valence electrons of the atom and subtract from it the electrons assigned to the atom in the Lewis structure. And that is the sum of the non-bonding electrons plus half of the bonding electrons. And the way I like to think about it is that is simply the number of sticks and stones around an atom. Let me show you why. So let's say that we have a Lewis structure, a random Lewis structure, and in that I have an oxygen atom that has a double bond and two lone pairs. So in this double bond, we are going to have four bonding electrons, right? So we need to take half of that. So that's basically just counting the number of sticks or bonds that I have. And the non-bonding electrons are the dots around the oxygen atom. So basically the stones, right? So 1, 2, 3, 4 stones and 1, 2 sticks, which is going to be 6. Okay, I'm going to show you another example. Let's do carbon dioxide and figure out which Lewis structure is the best. So carbon dioxide is CO2. Let's check the number of valence electrons. Carbon has 4, oxygen has 6. So 4 plus 2 times 6 is going to give us 16 valence electrons. Okay, carbon is the central atom, and I'm going to draw the bonds to the oxygen atoms. So I used up 4 electrons in the 2 bonds already. Let's keep track of that. So I still have 12 valence electrons to work with. Now I have to complete the octets for the oxygen atoms, right? Like so. So I used up a total of 12 electrons, and all my electrons are gone. Are my oxygen atoms happy? Yes, they are, because they have 8 electrons around them. Is my carbon atom happy? No, it's not, right? Because it only has 4 electrons around it in the 2 bonds. So what I have to do, I have to draw double or triple bonds. So let's say that I'm going to erase this here and add a double bond right here. And I still need 2 more electrons, so I'm erasing these 2 electrons and adding a double bond right here. Okay, is this the only structure that I can draw out of the 16 electrons that I have? No, there is actually another one. So I could have the carbon central atom, draw out the 2 bonds to the oxygen atoms, and make one single bond and a triple bond, right? So let's say I'm going to have a triple bond right here. So then this oxygen atom is going to have only 1 lone pair, but the other oxygen atom is going to have 3 lone pairs. Okay, so both structures seem okay to us, right? Because we in both cases have 8 electrons assigned to each atom. But which one is the actual correct one? Let's calculate the formal charges. So first, I need to know the number of valence electrons, and let's start with this oxygen atom right here. So in oxygen, I know that I have 6 valence electrons, and I know this from the periodic table. And then I have to subtract from it the electrons assigned to the atom in the Lewis structure, which is the non-bonding electrons plus half of the bonding electrons. So I just count the number of sticks and stones around this oxygen atom. 1, 2, 3, 4, 5, 6. So 6 minus 6 is going to equal to 0. So 0 is the formal charge of that oxygen atom. Let's do the same thing for the next carbon atom. So carbon has 4 valence electrons minus the number of sticks and stones. 1, 2, 3, 4, which is 0 again. Now let's do the last oxygen atom. 1, 2, 3, 4, 5, 6. So 6 minus 6 is again 0. Okay, so here on the top, I always have the number of valence electrons, and on the bottom, I have the assigned electrons right here. And then this is here the formal charge. So all the formal charges are 0, which is really cool. But let's check what happens with the other structure of carbon dioxide. So let's start with the first oxygen atom. We have 6 valence electrons minus the number of sticks and stones. 1, 2, 3, 4, 5. So minus 5 is going to give us a +1 formal charge. Then let's do this carbon atom. So we have 4 valence electrons minus 1, 2, 3, 4. So that's going to be a 0 formal charge. And then let's do the last oxygen atom. 6 minus 1, 2, 3, 4, 5, 6, 7, which is going to give me a formal charge of -1. Okay, so we actually need to have in the dominant Lewis structure the formal charges closest to 0. So in which one do I have the formal charges closest to 0? In the first structure, right? But what else is wrong with the second structure? Well, actually, oxygen is more electronegative than carbon. We know that if we just simply look at the periodic table, because electronegativity increases as we go left to right towards fluorine, because fluorine has the highest electronegativity in the periodic table, and oxygen is right next to fluorine. So it's impossible to have a positive formal charge on an oxygen atom next to a carbon atom, right? Because oxygen likes electrons more, so it would pull the electrons towards itself, okay? So this structure here, the second one, makes actually no sense based on the electronegativities. So this structure is incorrect, and this one is the correct structure. Okay, I hope this makes sense. In the next video, we are going to talk more about formal charges, Lewis structures, exceptions to the octet rule, and resonance structures. See you there.